Hello, this is Dr. Graves with part 2 of the Burbank Climate Lab tutorial videos. In this segment of the video, what we're going to do is to begin comparing our daily weather observations from the 3 study years, so these columns on the left, against the climate normal data over here on the right. And we're going to calculate first just the differences between the averages and the daily observations, and then we're going to convert those differences to a standardized score so that it can be placed properly on a normal curve. That will allow us to understand just how normal or abnormal any given day's weather is. So the first thing that we're going to do is to compare the precipitation on each of our observation days against the climate normal. This calculation is probably the least accurate of all because precipitation is highly variable in California, and so it's not surprising that you have many days with no precipitation. And the daily precipitation average, which is over here in this light green column, those are really an estimate of what it should rain on that day given a 30-year average. So let's proceed anyway. So in order to calculate the difference in average precipitation for each day, we're going to begin by placing our cursor in cell L2, click, and we'll type a formula, very simple, in this cell. Press equals to begin the formula, and you can either click on cell H2 or type in H2, minus sign, and then cell U2. So the formula appears as equals H2 minus U2, and you can copy that from the instructions as well, and press enter. And what you have is a negative 0.11, which is a negative 1/10 of an inch of rain. Normally it rains about 1/10 of an inch of rain on January 1st, but on January 1st, 2015, the precipitation total was 0, and so for that day we're just about 1/10 below what's average. This value isn't all that interesting by itself, but over the course of an entire year or even an entire month, once you sum the differences between what is normal and what is observed, then those individual days begin to make more sense. So what you're going to do is to copy this formula in cell L2 to the rest of the column of data. Once again, that's Control-C to copy. And then the easiest way to do this to copy down an entire column of data is to move your cursor to the lower right-hand corner of the cell in question and double-click after the cursor turns from a thick plus sign to a thin plus sign. So double-click, and the pattern is repeated all the way down to the bottom of the column. And you'll notice that this block of data that had previously looked like the columns or the blocks of data to the immediate right now has values, and you can see there that in cell L1101 that's highlighted that over the 3-year period of rain or period of study that there is a significant number of inches of rain below what we would expect based on the 30-year normals. So I've returned to the top of the data set and I've placed my cursor in cell M2 here just below TAV average diff. In this cell I'm going to calculate the difference between the 30-year normal average temperature for this day, which is in cell V2, and the average temperature for this day that we calculated earlier in cell I2. So type I2 minus V2 and hit enter. Going to repeat this process, and in this column we will calculate the difference in maximum temperature on the observed day and the 30-year climate normal. That's equals J2 minus X2, difference between the values in the red columns, and then we're going to repeat it again once more for the minimum temperature, and that's K2 minus Z2. Scroll over here just a moment so you can see that it is the values in these blue columns. I want to copy this data to the cells, or the column of blank cells below. So I highlighted these three formulas in cells M2, N2, and O2. I press copy, Control C, and double click in the lower right hand corner, and the entire column of data is now filled out, as are the averages, sums, minimums, etc. at the bottom of the data. So pause now and answer a couple of questions in your learning management software. Next, we're going to try to put into context the values that we just calculated. We see that this first day of January in 2015 was colder than normal. All of those values are negative, but just how cold are they? And how unusual is this? In order to do that, we're going to create a standard score, in this case a z-score, for each of these values. And in order to do that, we have to convert this formula from your lab instructions into a series of steps in Microsoft Excel. It's a relatively simple formula, and this is good practice for other sorts of calculations that you might want to do in a spreadsheet. So place your cursor in cell P2 and begin typing the formula. The formula asks you to take the difference between the two values, the observation on that day and the standard deviation. Well, we've already done the first part, which would have been I2 minus V2. That calculation is already apparent, or has already been completed in cell M2, so we don't necessarily have to do that again. We could, and we'll do it this way once, and we'll do it a different way next time. We take the difference between the daily observation and the climate normal and divide it by the standard deviation for that observation, or for the climate normal as it were, and that's 5.2, and that value is over in cell W2, so you can type in W2 and you press enter, and it shows you that this day was actually quite cold because it is negative 1.9615 below average, and that's sort of a magical number in the statistical world, 1.96. Crudely, we would translate that onto the normal curve and say that anything that approaches 1.96 has only a chance of about 5, or in this case, because it's negative, depending on the way you look at it, 2.5 chances per 100 of happening. And so this day really was unusually cold if we look at it in terms of the number of standard deviations. It is below average, and 1.96 is sort of that magical number that says this is statistically significant in terms of its difference from the average. So I'm going to press Control-C and copy that formula to the rest of the column, and we will see that on those days, if we take an example here of a day that the temperature average was only 1 degree above the climate normals, that the z-value is very small. Here's another one, just slightly colder, and the z-value is small, negative, but still small. There are other days that were much warmer than average. So this day the average temperature was 11 degrees warmer, and that's 2.2 standard deviations above normal, and that's would mark that day as unusually warm. So let's finish up this segment by repeating the z-value formula, one for daily maximum temperature, and we're going to do this the simple way and divide N2 by the standard deviation for daily max temperature, and we get a z-value of negative 1.2, and we will continue this pattern by dividing the difference between the minimum temperature and the 30-year average, and then by the standard deviation of minimum temperature. Copy that down to the blank cells below, and now we have a complete data set here and a number of calculations that have been calculated for us. Some of the most compelling data is in this lowest 2 boxes, which give us an indication of exactly, on a standardized score, just how cold these days were. So pause now. This is the end of this video, but there are questions for you to answer in your learning management software.